myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study and we are going to solve some of the problems on Hooke's joint. This Hooke's joint is the topic comes under the module number 3 in the topic of steering gear mechanisms. Steering gear mechanisms. So, in the steering gear mechanisms, here it is the subtopic that is Hooke's joint. In that Hooke's joint, another name of Hooke's joint is universal joint. Universal joint. So this universal joint is the joint is used in automobiles in order to transmit torque from engine shaft to rear axle. So here from engine shaft to rear axle. So where this is the engine shaft and it transmits power to rear axle with the help of this universal joint. So that universal joint is used to transmit torque from engine shaft is the main shaft that is known as the driver shaft and transfer to rear axle with the help of this universal joint. That rear axle connector shaft is a driven shaft. So the velocity of the driver shaft, the angular velocity of the driver shaft is denoted by omega 1 and angular velocity of the driven shaft is denoted by omega 2. In some of the books, in order to save themselves from the copyright point of view, what they did, they changed the notations. The angular velocity of the driver shaft is omega and driven shaft is omega 1. Okay, but in some of the books like Ratan, they followed that omega 1 and omega 2, whereas in our school mean this omega and omega 1 like that. So in order to protect oneself, but the problems of the concepts are remains the same and remaining notations also same. So here how to the maximum velocity, the ratio, the maximum angular velocity ratio or the maximum speed of the driven shaft, that is omega 2 maximum by omega 1 equal to 1 by cos alpha. This alpha is the angle of inclination between the two axes, between the axis of driving shaft to driven shaft. Now, and also one more is there, the velocity ratio of maximum and minimum. Yeah, it is the maximum and velocity ratio for minimum, that is omega 2 by omega 1 equal to cos alpha. Now, how to solve these velocity ratios and maximum speed of the driven shaft and the minimum speed of the driven shafts. Now, here, a Hooke's joint connects two shafts whose axes intersect at 25 degree. What will be the angle turned by the driving shaft when the velocity ratio is maximum, minimum and unity? Velocity ratio is maximum, minimum and unity. This means maximum means omega 2 by omega 1 is the maximum condition. Unity means omega 1 equal to omega 2. That is the unity. And second objective is acceleration of the driven shaft is maximum, minimum and 0. Minimum means negative and 0. Now how to start? As we have already solved these conditions of a Hooke's joint or universal joint in a proof, is the maximum condition is the maximum omega 2, the ratio of the velocity ratio, the angular velocity ratio is maximum when at theta equal to 0 degree and 180 degrees, and it is minimum at theta equal to 90 degrees and also 270 degrees centigrade, 270 degrees, not Celsius. Now, and it is unity when it is omega 2 equal to omega 1, the condition is that when That is the formula. This tan theta equal to when plus or minus root cos alpha, that is at 25 degrees. Mentioned here. A Hooke's joint connects two shafts whose axes intersect at 25 degrees. What will be the angle turned by the driving shaft when the velocity ratio is maximum, minimum and unity? So these are already proven. So velocity ratio is maximum at theta equal to 0 degrees and 180 degree, and minimum at 90 and 270, and it is unity when the condition is that when tan theta equal to plus or minus cos alpha at this 20 degrees, 25 degrees is the alpha, then tan theta equal to plus or minus 0.952, then theta equal to 43 degrees 35 units. This is 136 degrees and 223 and 316. These are the various angles where the ratio of or the driving shaft is equal to the driven shaft angular velocity. So it is the maximum angular velocity, that means unity means output speed by input speed equal to 1. When it is possible, when there is no friction, the coefficient of friction is equal to 0, completely null. At that moment, omega 2 equal to omega 1. Okay, that is the condition. Theta equal to 43 degrees, 133, 136, 223 and 316. Now, second objective. Acceleration of the driven shaft is maximum or minimum and 0. Now, so far we covered the portion of velocity, angular velocity ratios. Now it comes under acceleration. The acceleration of the driven shaft is maximum or minimum when cos 2 theta equal to 2 sin square alpha by 2 minus sin square alpha. To cos 2 theta equal to 2 sin square alpha by 2 minus sin square alpha. We know already alpha equal to 25 degrees. That is the only single data and you have to do it all. That means the whole angular velocity ratio, acceleration ratio is dependent on the angle of inclination between the two axes of intersection. Now 2 times sin square, what is the alpha? 25 degree. 2 minus sin square alpha, that is 25. That is equal to 0.196. Now cos 2 theta equal to 0.196. Then 2 theta equal to cos inverse of 0.196. Thus you calculate various angles. There are many more than. Now it is cos 2 theta. 2 theta is 78 degrees and 360 degree minus 78. Like the plus 78. 720 minus, like these are various angles where the acceleration is, what is the acceleration is of the driven shaft is maximum or minimum. These are the available angles. What are the angles are? 39 degrees, 140 degrees, 219, 320 degrees. All these round figures angles. At this point, what will happen? We can know either maximum or minimum. So let us, this is the acceleration formula. The acceleration alpha, that is acceleration A equal to minus omega 1 square cos alpha sin square alpha sin theta by 1 minus sin square alpha cos square theta whole square. This is the formula. Now the point is that in order to substitute, we know the theta, we know alpha. Alpha equal to 25 degree and theta equal to, just now we found all this, 39 degrees 21 minutes, 140 degrees 39 minutes, 21 degrees 219, 219 degrees 21 minutes and 320 degrees 39 minutes. These are the various angles. So the acceleration is positive when sin 2 theta is negative. Okay, that is negative, and negative when sin 2 theta is, and it is negative when sin 2 theta is positive. So why it is? Because minus into minus get cancelled, then becomes what? It is a positive, and when it is positive it becomes negative. So corresponding to these four values, what are the four values? Four values of 2 theta, that is 39 degrees, 140, 219, 290 and 320. Okay, so we can find out either positive, negative values we can get it. So after substituting, so the maximum acceleration will be at 140 degrees 39 minutes and 320 degrees at 140 and 320. These are the values we got positive, and minimum acceleration means negative acceleration we got at 39 degrees 21 minutes and 219 degrees 21 minutes. At those values we got minimum. That means at two angles of angle of theta we obtained or we observed the positive acceleration, and remaining two angles, the remaining two values of the angle theta observed negative acceleration. So acceleration is 0 when ratio of omega 2 and ratio of omega 2 and omega 1 is maximum or minimum. That is actually in general that cos theta, that is 0, 90 degree, 180 degree and 270 degrees. So our acceleration is 0 when 2 theta is 0, or when 2 theta is 0 is 2 theta, when 2 theta is 0, 2 times multiply it, this 90 degrees and all. 2 times 0, 0, 2 times 90, 180, 2 times 180, 360, and 2 times 270, 540 degrees. Or when theta is 0 degrees, 90 degrees, 180 degrees, and 270 degrees. These are the things one has to go through it. And finally, we obtained the various, where the angles are, acceleration is maximum at what angle. So at what angle acceleration maximum, we calculated. How we have calculated? The two objectives are these two objectives are very, very important in this problem. Again, so omega 2 and omega 1 is maximum at theta equal to 0 and 180, and minimum at 90 degrees and 270 degrees. And omega 2 and omega 1 is unity when tan theta equal to plus or minus under square root of cos alpha. This cos alpha we know 25 degrees. Substitute back in that equation in order to find out the angle, that is the theta value. That theta value is observed as the 4 values again. By substituting all these values, definitely in the formula we can achieve the maximum and minimum values. Okay, that is the first objective. The second objective is the acceleration of the driven shaft is either maximum or minimum when cos 2 theta equal to 2 sin square alpha by 2 minus sin square alpha. Though we know the alpha value, substitute back in this equation in order to obtain the values of the 2 theta, the angle values. That is 2 theta, it is observed as the 4 values. Among those values, after finding those theta values, by substituting the equation of acceleration, that is minus omega 1 square cos alpha sin square alpha sin theta by 1 minus sin square alpha cos square theta whole square. In that, by substituting the angles, after substitution only we got to know it what is the maximum and what is the minimum acceleration. So 39 degrees 21 minutes substitution at 219 and 21 at these two 1 and 2 degrees, these two values of theta, we observed the negative acceleration, and the remaining the values of theta by substitution we got to know it is a positive acceleration. So there are 4 values in that. Among 4, 2 values are positive and 2 values negative we observed. So this is what we have to find out. What will be the angle turned? That is what we have to find out. Not if after substitution of values we can obtain the value, we can observe the values of accelerations. But in this question it is asked only angle turned. What will be the angle turned by the driving shaft? Angle turned by the driving shaft when the velocity ratios, it is only angle turning. That's why we calculated only angle turned by the driving shaft at various speeds of velocity ratios and also acceleration of the driven shafts. Okay, now this is the condition. Next, in order to find out in the next problem, we can see this is another model. So far we covered all models. Now we are going to practice the few problems based on the same models. So two shafts with an included angle of 160 degree are connected by a Hooke's joint. The driving shaft runs at a uniform speed of 1500 rpm revolutions per minute. The driven shaft carries a flywheel of mass 12 kilograms and 100 mm radius of gyration. Find the maximum angular acceleration of the driven shaft and maximum torque required. Okay. There are again, it is here, there are two objectives are there in order to find out the maximum angular acceleration. This is the maximum angular acceleration of the driven shaft and the maximum torque required. The maximum torque acceleration of the driven shaft and the maximum torque required. It is extra objective is that there is maximum torque. Now, in the given data, the two shafts with an included angle of 160 degree, that is included angle of 160 degree, that means alpha equal to 180 minus 160, that is 20 degrees, are connected by a Hooke's joint. The driving shaft runs at uniform speed. That is 1500 revolutions per minute. That is considered, that is equal to N1, or in some other books they followed as N, that is 1500 RPM. Now, M mass equal to 12 kilograms, that is a flywheel, and radius of gyration, that is R, K equal to 100 millimeter, that is 0.1 meter. We know that from that N we can substitute as in omega, that is omega equal to 2 pi times N by 60, that is 2 pi N by 60, 2 pi times 1500 by 60, that is 157 radians per second. So, what is the mass moment of inertia? That is I equal to mk square. Substitute in this, m equal to 12 kg, k equal to 0.1, mk square, 0.12 kg meter square. This is mass moment of inertia. So, very important point here it is, why we consider only mass moment of inertia, why not area moment of inertia? This we are talking about flywheels, flywheel having a certain weight, volume consideration and weight consideration, density considerations. Whenever we are using the components and density considerations, there we have to use for mass moment of inertia, mass movement. And whereas area moment of inertia, that formula to be used where only for plane areas, plane geometries. So that's why we considered mass moment of inertia here, because the flywheel having certain mass, okay, and having certain weight. That's why we considered as consider a mass moment of inertia in this solving the problems. Now, let us define the maximum. What is that definition? What is the shaft here? Maximum angular acceleration of the driven shaft. For that, we know the formula, that is d omega 2 by dt. Actually, we followed in some of the textbooks, but here we are following is d omega 1 by dt. This omega 1 is angular velocity of driven shaft. Okay. Then d omega 1 by dt means what? Rate of change of angular velocity. That means angular acceleration. That it is angular acceleration of a driven shaft. And theta is the angle through which the driven shaft turns. Now, for maximum acceleration, cos 2 theta equal to, we know the formula, that is cos 2 theta equal to 2 sin square alpha by 2 minus sin square alpha. That is 2 sin square alpha is 20 degrees by 2 minus sin square 20. That is 0.124. Then 2 theta equal to 82.9 degrees. Then theta equal to 41.45 degrees. Now, we know this d omega 1 by dt. Make this equation, okay, differentiate with respect to the term, the d omega 1 by dt equal to omega 1 square cos alpha sin 2 theta sin square alpha by 1 minus cos square theta sin square alpha whole square. This is the acceleration. We already studied acceleration of driven shaft. The previous problem, this is the acceleration of driven shaft. Okay, cos square alpha by. In the place of omega 1, in this term here, omega 1 is what? Angular velocity of a driving shaft. That is what we mentioned here. That is the angular velocity of a driven shaft omega. Cos alpha sin 2 theta sin square alpha by 1 minus cos square theta sin square alpha. We know the omega 1. What is that omega? 2 pi n by 60. What is omega equal to 157 radians per second. Substitute back in this formula, 157 whole square, cos alpha, that is cos 20, sin 2 theta, 2 times theta. What is the theta here? Angle 41.45. For sin 2 theta, sin 2 times 41.45 times sin square alpha, that is 20 degrees by 1 minus cos square theta, 41.45 sin square alpha 20. After substitution and getting calculation, the observed value is 3090 radians per second square. This is the first objective we calculated, that is maximum angular acceleration of the driven shaft. So this maximum angular acceleration comes, first we found out cos 2 theta, what is the angular, that angle of turn by through which driving shaft turns. After calculation, we acceleration formula, we substitute both alpha and theta. So now here very important interpretation, we can understand that angular acceleration is dependent on three parameters. Angular acceleration of driven shaft is dependent on angular velocity of the driving shaft and angle turned by the driving shaft, and also the angle of inclination between the two axes, that is alpha, omega, theta and alpha. So theta and alpha, where omega is remains constant, because here it is uniform velocity or uniform angular, that is 1500 revolutions per minute. Now what is the variables theta and alpha? Theta and alpha, this means angular acceleration of the driven shaft is dependent on theta and alpha. So now if you consider theta is remains constant, that is 41.45, both omega and theta are constants, then what is the variable alpha? So that whenever alpha varies, the alpha is varying, then angular acceleration of the driven shaft will be varied. That is the interpretation point from this problem. Now the maximum torque equal to, what is the maximum torque required? The maximum torque required, that is, we know that the maximum torque, that is I times acceleration. I'm not using I alpha because alpha I already used that parameter, that notation for angle of inclination between the two axes of the driving and driven shafts. Now the maximum torque that equal to I times acceleration. Now I times acceleration, we know the mass moment of inertia I, that is 0.12 kg meter square. Acceleration, that is 3090. What type of acceleration here it is the maximum acceleration of the driven shaft. That's why the torque we are calculating when it is for mass moment of inertia times acceleration, angular acceleration of the driven shaft. That is 0.12 times 3090, that is 371 Newton meters. So in this manner, we have to calculate the maximum torque required and the maximum angular acceleration of the driven shaft. Okay, thus we have to calculate. So these are the problems we observed. Now suppose here they have given mass moment of inertia. So mass of the flywheel was given and also radius of gyration. So that's why we calculated. If it is not, those parameters, mass and radius of gyration are not given, then there will not be the question, problem won't be asked the maximum torque calculation. The maximum torque is dependent on, what are the parameters it is dependent on? The torque is dependent on because mass moment of inertia of the flywheel remains constant. This is I is the constant. I means it remains fixed. It won't be varied in this case. So it's dependent on acceleration. Which acceleration? Angular acceleration. We are considering as acceleration angular acceleration of a driven shaft. Angular acceleration of a driven shaft. So with angular acceleration is increasing, that is d omega 1 by dt is increasing, then maximum torque the torque T will be increased disproportionately. So that's why. So this angular acceleration of the driven shaft is dependent on, again, it is interdependent, is dependent on which one, that is angle of inclination of the shaft between two axes. So that's why here the torque is maximum when the angular acceleration of the driven shaft is maximum. That is the conclusion in this. Next problem, if we want to solve, next problem, the angle between the axes of the two shafts connected by Hooke's joint is 18 degree. Determine the angle turned through by the driving shaft when the velocity ratio is maximum and unity. The angle between the axes of the two shafts connected by Hooke's joint is 18 degrees. That is alpha equal to 18 degree. Determine the angle turned through by the driving shaft when the velocity ratio is maximum and unity. So here alpha equal to 18 degrees and theta equal to angle turned through by the driving shaft. So we know that velocity ratio is maximum, that is when it is maximum, cos alpha by 1 minus cos square theta sin square alpha. It will be maximum, the velocity ratio will be maximum when this term cos square theta is maximum, when cos square theta is minimum. If it is minimum, the value becomes maximum. So when cos square theta equal to 1, when it becomes 1, whether theta equal to 0 degree or 180 degree. So cos square theta equal to 1, when theta equal to cos square theta equal to 1, then what will happen? Omega 1 by omega equal to 1 minus 0 1, that equal to cos alpha. This is the maximum. So as we have studied in some of the textbooks, it is mentioned omega 2 by omega 1 equal to, actually max is when cos square theta is minimum. But it will comes 1 by sin square alpha. No. Yeah, cos square theta equal to 1. It is 1 minus sin square theta. It becomes 1 by cos alpha. If you simplify it, that is the condition. When cos square theta, omega 2 by omega 1 equal to 1 by cos alpha, it is for maximum velocity ratio. And it is for minimum velocity ratio, omega 2 by omega 1 equal to cos alpha. That is one. Next, when the ratio is unity, that is omega by omega 1 equal to 1. We know the formula that omega 1 by omega, that makes unity. Then what will happen? That equal to 1. Cos alpha equal to 1 minus cos square theta. 1 minus cos square theta sin square, 1 minus cos square theta sin square alpha. So it becomes unity, that equal to 1. That equal to 1, then what will happen? Cos alpha equal to 1 minus cos square theta sin square alpha. So further simplification, if you simplify it, cos square theta equal to 1 minus cos alpha by sin square alpha, the final value comes, alpha we know that alpha equal to 18 degrees. So cos alpha equal to 18 degrees, further simplification, theta comes. The theta is obtained as 44.3 degrees or 135.7 degrees. At these two angles, the velocity ratio becomes unity. What is the theta is? Theta is either 44.3 degrees centigrade, 44.3 degrees or 135.7 degrees. At these two angles, the velocity ratio, what is the velocity ratio? The speed, the angular velocity of the driven shaft to the angular velocity of driving shaft. That ratio becomes unity. That becomes unity means, what is that? 100%. There is no friction loss. The driving shaft speed is equal to the driving shaft speed is equal to driven shaft speed. That is the meaning when it becomes unity. Thank you. In this session, we studied problems on Hooke's joint by considering mass moment of inertia and also maximum torque calculation, maximum acceleration, angular velocity of the driven shaft calculations, and also what is the angle turned when the velocity ratio is unity. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.